Today we start with numbers. Numbers are everywhere. In your wallet, on your smartphone, in your mom's shopping list. As a kid, the first mathematical concept we deal with are numbers. So it is logical that the first topic of our tutorial is types of numbers. In this lesson, we'll explore natural numbers, whole numbers, integers, rational and irrational numbers, and finally, their elder real numbers. Don't forget to subscribe to my YouTube channel, Math with Behnam. Okay, first of all, we start with natural numbers. They are called counting numbers too because we use them for counting things. 1 apple, 2 apple, 3 apple. This is the set of natural numbers. The notation of natural numbers is capital letter N. It is the first letter of the word natural. Let me give you an example. I ate 3 pizzas. 3 is the natural number. Don't judge me, it was my cheat meal, as well as in Italy, 3 pizzas is just called a breakfast. Okay, the second group of numbers, my friends, are whole numbers. Whole numbers actually is the natural numbers with 0 bonus. The only difference between whole numbers and natural numbers is 0. So this is the set of whole number. The notation of whole numbers is W. W is the first letter of the word whole. Let me give you an example, a familiar example. A bank account balance after shopping is gonna be 0. 0 is a whole number. It's a familiar example for all of us most of the time. And what a shame. Okay, it is obvious that N is a subset of W because every member of natural numbers is in whole numbers. One step bigger, integer numbers. Integers are whole numbers plus negative value. It is the set of integers. 0, 1, 2, so forth. -1, -2, so forth. The notation of integers is Z. Maybe you ask me there isn't any Z or Z in integers. You're right, because it's the first letter of Zahlen. It's a German word that means number. Okay? Let me give you an example. Temperature in Canada in winter is -20 centigrade. But we know that Canadians call that a bit chilly. My man. It is crystal clear that N is a subset of W and W is a subset of integers. One step further, rational numbers. They can be expressed as a ratio, as a fraction of A over B. A is called numerator, B is called denominator. Both of them are integers and B is non-zero. This is the definition of rational numbers. Some examples, my friends. -3 over 2 is a rational number because -3 and 2 both are integers and 2 is non-zero. Another example, 5 is a rational number because the denominator is 1 integer over integer, so it's a rational number. From this, we can conclude that all integers are rational number. Another example is 0.7. All terminated decimal numbers are rational because we can write them as a fraction, 7 over 10. Another example is this unterminated decimal number. We can rewrite it in this form, 0.75858, so forth. 58 is the repeating string. All unterminated decimal numbers with repeating strings belongs to rational numbers. The notation of rational numbers is the capital letter Q. There isn't any Q in the word rational, but it's the first letter of this Italian word. Quotiente means quotient. It is obvious that N is a subset of W. W is a subset of Z. Z is a subset of rational numbers. Let me give you another sweet example. Me as a child, I want 1/2 of chocolate bar, Mom. My mom replies, you'll get 1/4 of it and be happy. Okay, the next category of numbers are irrational numbers. First 2 letters of this word emphasize that it is the complement of rational numbers. So the definition of irrational number is numbers that cannot be expressed as a fraction. Some examples. Every radical number that can't get rid of radical belongs to irrational numbers, like square root of 3, third root of 6. And every unterminated decimal number without repeating string belongs to this category, like 0.568, so forth. Like the most famous constant in mathematics, pi number, 3.14, so forth, without repeating string. I will talk more about decimal numbers in next session. The notation of irrational numbers is q prime, and it makes sense because, as I said, it's the complement of rational numbers. And finally, their elder, real numbers. Real numbers are union of rational and irrational numbers. So in number line, every number you can imagine belongs to real numbers set, like 0, like square root of 2, like minus third root of 6, like 4 over 1, like 100 over 3. All of them are real numbers. Let me give you some examples. Square root of 2 is a real number and it's irrational. 0, it's a real number and it's rational. 2 over minus 8 is a real number and it's rational. And Euler's number, one of the most famous constants in mathematics, is a real number and it's irrational because it's an unterminated decimal number without repeating string. The notation of real numbers is R. It is the first letter of the word real. Let me summarize what I've told you. Consider this as real numbers. This part is natural numbers, this set. One step bigger is whole number, this set. One step bigger is integers, this set. One step further is rational numbers. The mathematical definition of rational numbers is this. I've told you that n is a subset of w, is a subset of z, and it is a subset of q. But the other part of real numbers is called irrational numbers, or q prime, which is equal to r minus q. Some examples. Pi number is an irrational number. Square root of 7. Square root of 121. Is it an irrational number? I hear your voice. No, it is not irrational because it equals to 11. I've said that to you, that every radical that cannot get rid of radical is irrational. Okay, let's check comprehension. It's your turn. This is the question. What is the sum of rational and whole number among the numbers below? Drop your answer in comments. And don't forget to subscribe to my channel, Math with Behnam, and my Instagram page, Math with Behnam. Feel free to direct me. I'm always there for you. Thank you so much for your attention.